Yes. Good morning, everyone. So let's start the today's session. So yesterday we had a kind of a demo session, right? In which we haven't discussed any technical things. Just we had some basic overview, like how these sessions are going to be, and just a kind of introduction about myself and how the market is. That's what we discussed in the yesterday session, right? Okay. So today's session is about understanding why DevOps exists. Give me a second, guys. Just a moment. Okay. So today's session is about understanding why DevOps exists before we start learning the DevOps tools. The reason is without knowing the concept, right? Without knowing the actual concept, if we start learning the tools, that's not a good idea. You can't, like what we call that, implement, or we can't use the tools effectively in the real time. So you must understand the basics of what we are going to learn. This session is a conceptual session, most probably hands-on starts from the upcoming classes because this is completely about a theory, like learning about the concept. Okay, so today's agenda is going to be like learning what is DevOps, what is SDLC, what are the different SDLC models available, Waterfall versus Agile versus DevOps. That's what we are going to learn, right? Before DevOps, also there are some methods, some models. So why they were not that, I mean, I'm not saying those are not popular. Why DevOps exists, right? Okay. Before I explain DevOps, let me tell you a small story. Imagine like you came to a restaurant, right? And you ordered a food from a restaurant. I mean, in that restaurant, you ordered a food, right? So how you order, like whenever you go to the restaurant, you will take your seat. So someone will came to you and they will take the order, right? They will take the order. And the moment once the order has been taken, the chef starts preparing the food. So here, one team cooks the food, right? One team cooks the food, and another team delivers the food, right? One team cooks the food, and the other team delivers the food. So what if they don't, what we call that? They don't uh, talk to each other properly. If there is no proper communication, what exactly will happen? What will happen if there is no proper communication? They can't deliver the food. They can't deliver the food in a proper way. Food might get scored. Like let us say, so here he came to you, right? He came to you, and like you ordered the food, right? And then he went to chef and he informed about the food to be prepared. So he prepared the food, right? And he kept aside. He prepared the food and he kept aside. There is no information from the cooking team to the delivery team. Then what happens? This food gets cold. After 30 minutes, he again came back to the cooking place or a chef. He gave the cold food and he delivered that cold food to the customer. That is the one problem. The second problem, at the same time, the chef might prepare multiple orders, right? This is for customer one, this is for customer two, this is for customer three. If they don't talk to each other properly, if these two teams are not communicating effectively, then what happens? Wrong items are delivered to the client. So here the proper communication is important, right? In this example, one second. Sorry. So software companies facing the same problem. So in software companies, there are two important teams. Software companies, there are two important teams. One is a development team, and the second one is operations team. One is a development team, and the second one is operations team. What do you mean by like what we call the development team and what is the operations team? What exactly they do? One second. Just give me a second, guys. Something went wrong and the controls are not working. So let me close. I mean, not closing the session. Just let me close the window and let me reopen. Okay. I guess the issue got resolved. Let me share my screen. Okay. It's okay. Okay, where are we? Just we had some example, right? We had an example about the problem if we, without effective communication. That's where we stopped. Sorry for that. Now, in software companies, there are two important teams. Software companies, there are two important teams. What are those? A development team, and operations team. So here you can see this is the assume this is the development team, right? What exactly they do? What the development team will do? They write the code, they will add new features to the applications, right? And here, this is the operations team. What's the job of the operations team? Whatever the code is designed or the applications developed by the developers, this operations team deploy those applications or those softwares into the production. Like they will manage the servers, they will deploy the applications, they will make sure that the application is stable with a high performance and all. And here both teams are important, like development team and the operations team. Both teams are important because they are mandatory teams, or they both the teams are involved in order to provide the application to the end users. But here the problem is earlier these two teams worked individually. There is no proper communication, there is no proper integration between the development and operations teams. They are worked in a different separate way. Developer will say always like code works in my laptop, and operations team says production is down because of your code. They don't accept or they don't agree that there is a problem with coding or there's a problem with the infrastructure level. They will start like blaming each other. This gap is the reason DevOps was introduced, just to establish a proper communication or a proper integration between the development and operations team. That's why you can see Dev stands for development and Ops stands for operations teams. So now, can you guess what might be the DevOps is? Can you define what is the DevOps? Can you define what is the DevOps? Anyone? Even though if you are defining wrong, no need to worry. So here we are not what we call that a professionals to make it correct everything on the day one itself. Okay. Can you define what DevOps is in your own words? No need of a technical definition and all. Whatever you know, just let me know in the comments. Let me know in that chat box. Any guess like what this DevOps means? Because few people might say DevOps is the combination of development and operations, right? Based on my explanation, majority of the people might think in that way. DevOps is the combination of development and operations. But we are not, I mean, even though that's the correct, but that's not, we are supposed to explain if someone asks you about what is a DevOps. That's not the proper way. Okay, do you think a DevOps is a new technology? Do you think DevOps is a new technology? How many of you agree that DevOps is a new technology or a new coding language? That's not true. DevOps is not a new technology, actually. DevOps is a process or a methodology or a method. DevOps is not a technology or DevOps is not a kind of a new language. DevOps is a cultural philosophy, set of practices and tools that integrates software development team. So here you can see this is a software development team and the IT operations team. Why? Why to integrate these two teams? There must be some reason, right? You might say, okay, so that they can talk to each other in effective way. Why? What is the importance of making the communication effective between these two teams? To make something better, right? To make something better. What exactly that is? To automate the integration between these two teams is to automate and integrate the processes, whatever is designed or whatever is performing by these two teams will be integrated. For what reason? Why we are integrating? To deliver the software faster and reliably. If you are doing something means there must be some better outcome, right? So DevOps is a cultural philosophy, set of practices. It has some rules, we can say. We must follow those set of practices and tools which integrates software development team and operations team. For what reason? To automate and integrate the processes. To automate and integrate the processes. Why to automate and why to integrate? To deliver the software faster and reliable. Earlier, deploying software used to take like weeks or months. Why? Because of manual server setups. Whatever is done by the operations team is a manual process. Manually setting up the servers, manually copying the files, manually installing, manual testing, everything is manual. With the DevOps, this entire process is automated. So now, whenever the developer write the code and whenever the code is pushed, whenever the code is pushed, you can say code is delivered, the tests will run automatically and application gets deployed automatically. This is the DevOps in action. This is what exactly the DevOps is. Being a DevOps engineer, we are going to automate the things from the development to the deployment, which we will discuss in detail in the next few minutes. Okay, so now we need to learn about a term called SDLC. Do you know what is the full form of SDLC? Software Development Life Cycle. Software Development Life Cycle. Can you guess what might be this software development life cycle is? What is this? SDLC. Oh, okay. Before getting into the SDLC, I have a question. Let us say you are planning to build a house. Okay, you have a land, you have an open land, and you are planning to start building a house. You have some, you have some like a dream project to build a house as per your thoughts or as per your wish, as per your interest. Now the question is, can you start building a house without a planning, without having without having a plan? Like, can you build a house? No, right? You can't. Software is built exactly like a house. Software is built exactly like a house. You can compare with your house construction. First, you need to have some kind of an open land. Then you need to go with some planning, like how many rooms it should have, what should be the dimensions, or like how many washrooms to be there, and how many floors, what facing, like east, west, north, south facing, right? So you have a lot of things. Then you will purchase some material. Then you will hire some a team who will construct the building, right? Planning team is different, construction team is different, and you will coordinate with them to make sure that plan is getting executed properly, right? The software is built exactly like a house. Now, coming back to this SDLC, SDLC is a step-by-step process used to build a software from an idea to a real application used by customers. Even the building a house, you have some idea, right? You have a rough idea, like it should look in this way, right? So here is one room, here is like a living room, bedroom, something like this. You have some idea, right? Based on the idea, you will design a blueprint, you will plan it, right? Then you will start like Azure, like calculating uh, how many tons of cement required, how many tons of sand, how many tons of steel, right? Everything you will plan. Then you will start development. The same way the software. So here the SDLC is a step-by-step process used to build a software from idea to a real application. Every company follows SDLC, whether they call it SDLC or they don't, that doesn't matter. But every company will follow SDLC, every software company. Any guess when this SDLC was evolved or introduced? It was evolved, it was evolved during 1960s. In the year 1960s, this SDLC, software development lifecycle, started evolving. Actually, the SDLC is a concept or a framework. SDLC is just a concept or a framework, not a model. What is the meaning of a concept or framework? These are the recommended methods, or these are the recommended steps to follow in order to get some so and so. And it is introduced to bring a discipline and a structure to software development. It was not developed by what we call that a single person. This SDLC framework was introduced by a software engineers and some system analysts working for a large or a central government cost. Central government in the sense like in that particular country, like government projects, enterprise systems, right? Because they feel that designing the software and everything is a little bit complex. So if you follow some set of rules or some set of instructions, it will bring discipline and a proper structure to the software development. So why we are not a developers, but why we are learning the SDLC? Because being a DevOps engineer, the DevOps will take care from the development phase to the deployment phase. That doesn't mean we will start developing the applications like writing the Java code, .NET code. You must know the end-to-end life cycle. Okay, here I use a term called life cycle, right? Life cycle means end-to-end. What is the life cycle of a human being? Infant, child, teen, adult, right? These are the different phases in the life cycle. These are the different phases in the life cycle. In the same way, in the software development life cycle, also, we do have a phases. These are the different phases. So actually here in the image, you can see 7 phases, but in the real world, they might consider it as 6 phases. What does that mean? They did missed one phase? No. They combine these two together. They combine these two together and they made it like one phase called requirement gathering. Okay. So what does that mean? Actually, there are a seven phases, but in the market, you can see only in this, you can only see 6 phases. Why 6 phases? They combine planning and analysis to a single phase called requirement gathering. There is nothing wrong in that. Almost every company, if you go for any interview and if you say uh, SDLC is having 7 phases, that's not wrong. But they might ask you, can you explain what are those 7? Or if they say only 6, like requirement gathering, design, development, testing, deployment, maintenance, that's true. You have to say requirement gathering is the combination of planning and analysis. Okay, let us try to understand what happens in each phase. So let us combine the planning and analysis together because you can't do planning and analysis individually. If I let us say if I am planning, if I don't analysis what I am planning, it's a time waste, right? That's why that was merged into one phase called requirement gathering. In this phase, business talks to customer. Let us say you are the customer. You have planning of get creating an application. So you came to my organization. So I am the business. I will talk to you. You will explain what exactly you want. So there is no coding started. There is no coding started yet. Just we are discussing. I'm getting your requirement, like what is your plan, what exactly you need and all. Let us say you are saying, client says, I want an application. I want a simple application where users can log in, they can log in and they can order something from my application. Remember, always the clear requirement is the key step for a successful project. In the requirement gathering stage, we will collect the requirement of a client. We, in the sense, we are not going to be a part of the planning phase. We will never involve into requirement gathering meetings, design phasing meetings, and all. Okay. Just these are the phases in the SDLC. Once the requirement gathering is done, it will move to design phase. What happens here? Here, the team, the architect team will design the application architecture. What exactly the application architecture means? So what programming language to be used, what database to be used, and how the database schema should be. Let us say uh, uh, Java to be used and MySQL database to be used. UI flow, like how the home page looks like, or how what should happen if they click on login page, where the image to be displayed, the UI or UX flow will be designed, technology stack creation, like whether it does it require any load balancer, auto scaling to be used. The entire thing will be designed in this particular design phase, right? Like how many servers to be created, what database engine to be used, how the login should work. It's like the blueprint of your house. Designing is like a blueprint. Based on the requirements of the client, we will design the plan, we will design the architecture. Then once the design is approved, it will move to development phase. What happens in the development phase? Developers start coding and the features are implemented, like they will implement the login feature, order like cart page, and place order, payment gateways. All the features will be introduced. Once the development is done, it moves to testing phase. What happens in the testing phase? Application will be tested. If there are any bugs, they will be identified, and that will be informed to the developers, and the developers will fix those issues. Once testing is done, once the testing is completed, the application is ready. All the issues were resolved, which means the application is ready. Then what is the next phase? A deployment. What is a deployment? In the deployment, application is released to the production. Users start accessing it. Servers are configured. The application is live, right? This phase is where DevOps becomes very important because we don't do any manual testings. We don't do any kind of testings that will be taken care by the QA team. Coding, development, that will be taken care by the developers. And the deployment, the DevOps are going to be very crucial. Once deployment is done, all the servers are up and running. Maintenance is the most important thing in the real time. Maintenance is most important. What exactly the maintenance is? Monitorings will be configured, observability, we can say, right? And we will monitor what's happening, like what is the performance, what is the response time, what is the latency, everything will be monitored. That is the first thing. And bug fixes, like once it is deployed, right, there might be some issues identified by the user. So based on the issues, the developers will give you some fixes. That fixes will be deployed, and a few users might complain that the application is not up to the mark, like the response is very slow. So that we will tweak something and we will improve the performance. Like we will observe if the CPU is getting utilized more, then we will increase the resources. And the developers might ask to change some configurations. They will suggest some recommendations, right? That will be updated to improve the performance. Monthly maintenance like security patches or the software upgrades, right? And the new features. Once the application is ready, that's not the end of the life. Again, whenever there's a new requirement provided by the client, again the SDLC phase starts from requirement gathering. If the app is slow, optimize it. If any bug is reported by the user, we will fix it. New feature is requested or implemented, we will add it to the production. This is all a part of a maintenance. And after the maintenance is complete, the application is successfully running in the market, running in the live, right? But if a new requirement comes, SDLC starts again from the planning phase for the new feature to be added. Like, let us say, after ordering, it will take you to the payment page, right? As of now, the payment is only supported by the cards, credit or debit cards. I think you guys know that UPI payments are very popular nowadays, right? So the client need the payment by UPI. That's a new feature, right? That will be added later on stages during the maintenance phase when the client will come back and okay, we need UPI payment support. We need UPI payment support. Yes, that again, from the planning phase, everything will be started, planning, analysis, design, development, and that will be deployed. Again, there will be a maintenance. Now that you understand SDLC, right? Software Development Lifecycle. Let's talk about the first and oldest way companies followed SDLC. That way is called a waterfall model. It was described in 1970, in the year 1970. So waterfall model is a development approach where each phase of SDLC is completed fully before moving to the next phase. So here, let us see this. This is the waterfall model. Like this is how we can represent the waterfall model. Let us take the same example. You are the client for my organization. So we are in the requirement gathering phase, requirement analysis. So We had a meeting. So you need a login page, right? You need a login page. Then you need a order page. So I got all the requirements. Once all the requirements is collected, then only I should go to the design phase. Before getting the before getting into the next phase, we need to lock the previous phase. Or in other way, we can say once a phase is completed, we do not go back. I will make it more clear. So I got the requirement from you. So my product architect team designed the system, like what technology to be used, let us say Java and a MySQL database. Then in the implementation phase, implementation is nothing but a coding or a development. My developers started, like, what do we call that? Developing the application. Now, after 1 week, you came back to me and you say, okay, in the login page, I need a OTP. In the login page, whenever the user is getting logged in, along with the username and password, I want to enable two-step verification and I need an OTP to be entered. Here, you can't go back and you can't change the requirements. So everything you have to stop and you need to start from the requirement analysis again. You finish the you finish the requirement, just move to design. Finish the design phase, move to development. That's it. No reverse movement in the waterfall model. Major problems with the waterfall model is there is no flexibility. If requirement changes, waterfall breaks. Late feedback. Late feedback. What does that mean? So here there is one more problem. Implementation, right? Until the developers complete the entire coding of login page, order page, and everything, the testing team cannot start the testing of the product. They can't test a single feature or something in the waterfall model. Entire application will be ready in like in few months. Then the QA team will start testing it. What does that mean? Like for the next 2 3 months, QA team doesn't have any work, which means we are wasting the man hours. Late feedback until the product or the application is fully available or released or live in the market, we don't get any feedback from the client because the client only sees the product at the end. If client doesn't like it, again you have to start from the requirement analysis phase, which means time is wasted and money lost. And this waterfall model is at very high risk because if mistakes happen early, let us say in the system designing phase, if we do some mistake, we can't identify it until in the deployment or maintenance phase. We discover them very, very late. Slow delivery with the waterfall model, the application or the software will be delivered very late, months or years before the user sees anything. Waterfall is only useful when the requirements are very clear, requirements will not change, or for small projects only. But I can't say waterfall model is a failure model. It is not a failure model, actually. It is a good model because it was introduced in 1970, right? Do you know when the next model came into the market? Waterfall model is having some challenges that we agree, but that's not because of what we call that inability. And we don't say waterfall model is a failure model. Waterfall failed not because it was wrong, but because the world started changing faster. That is the thing. Waterfall model was introduced in 1970, and there is no other popular model until 2001. Okay, so you understand the waterfall model, right? It has a lot of challenges, right? Now let's understand why companies moved away from the waterfall model into the agile model. I think you might heard agile term very like frequently, right? Agile methodologies, agile company, right? Yes. This agile model was introduced in 2001. Again, it is not also introduced by a single company. It is by some agile manifesto authors. Like I think it's like it's a group of 17 software experts. The biggest problem with the waterfall model was change. Whenever the requirement changed, waterfall could not handle the changes, right? Now, agile is a way of developing software in small steps. Let us say the client gave us a requirement, right? In that application, the requirement is a login feature. Then there should be a dashboard. These are the requirements in the application. Then payment page, and some notifications like email notification to the customer, like whoever purchased the product, or a text mobile notifications. These are the requirements to be included in an application for the customer, right? Okay. For a few minutes, keep this requirement aside. Let's talk about the agile. Agile means a flexibility, like where quick feedback and adapting to changes. Whenever there is a change in the requirement, we will adapt to the new changes. Agile delivers small features quickly, get feedback early, and improve continuously. Let's take the example of your mobile phones. Like nowadays, everyone is using the mobile phones, right? Smartphones. And it can be Android or it can be iOS devices, right? So, do your mobile apps, the applications, your mobile phones, do they release the update once in a year? Let us say you are using, let us say, the WhatsApp, right? Or Instagram. I think Instagram is a more popular nowadays, right? Everyone is using. So if you see the Instagram application, in a year, do they release updates, a newer app version multiple times or only one time? They will release multiple times in a year, like every 2 months, 3 months, but they don't include huge changes. Like app get updated every few weeks, but with just one or two feature updates at a time instead of lot of features at once. Let us say uh, the new app version to be deployed with the 10 different updates in the application. So this might take 3 months of time. So what that person will do, what that company will do, instead of developing 10 updates, they will divide the 10 into 5 parts. In the first phase or in the first cycle, let's deploy or let's release 2 updates. In the second cycle, 2 updates. Like this, they will split that entire requirement into smaller portions so that this will get released in the first 10 days. This will be released 10 days. So the user will feel, okay, every 10 days, I'm getting an update. I'm getting a new feature added into my application. This is how exactly the agile methodology works. So the in the agile model, we will break or not break, we will split the entire work into small pieces. And each piece we will consider it as like a sprint. So here the sprint one, we will perform login. In the sprint two, we will design the dashboard. And in the sprint three, we will add the payment option. In the next sprint, we will add some notification. So each piece is manageable. A sprint is a short development cycle. It is a short development cycle, usually like a 2 to 3 weeks or a 1 month, depending on like what features you planned in that particular sprint. We don't call it as a cycle. It's a sprint. Technically, it is a sprint. Sprint, sprint. A sprint is a short development life cycle, usually 2 to 3 weeks. So, in one sprint, we will plan, develop, a test, a review. At the end, working software is ready, but not the entire application. After completing the sprint one, we will get a basic application with just a login feature. After completing the sprint 2, you have an ability to log into the application and you can open the dashboard and you can see the overview. After completing the sprint 3, your application will have the payment facility, right? So then continuous feedback after each sprint. So after each sprint, some product, right? Some features are available to the customers. You will receive reviews from the customer, feedback is given, changes are suggested, right? Those changes and those feedback will be considered and that will be implemented in the sprint 2. Customer does not wait for 6 months to see his final product. After every 1 month or after every 2 to 3 weeks, he can see what the new version of his application. And in this agile, iterative improvement, each sprint improves the product. How? In the sprint 1, the product is only having the login feature. But after sprint 2, the product gets a dashboard facility, like add new features, fixed issues, improve design. Agile is about learning and improvement. The benefits of the agile is faster delivery. Instead of waiting for 6 months, every 1 month or every 3 weeks, we are delivering something to the customer, right? Early customer feedback, we will get a feedback from the customer so that reduced risk, better quality, and happier customer. But in the agile model also, we do have some limitations. I don't say those are the drawbacks. We can say limitations or challenges. In this agile only focuses on development. If you observe, this development got improved when comparatively with the waterfall model, right? The performance got improved. It is getting adopted by the changes. New requirements will be considered and they will be implemented in the next sprint, right? But the deployments in the agile model is often still manual. This agile model doesn't focus on the deployment. It focused only on the development. Operations team is still separate. Operations team is still separated. They are not integrated in the agile model. Production issues still exist. This agile model solved the development problems, but deployments remained. Agile improved how software is built, and DevOps improves how software is delivered and maintained. Agile improved only how the software is built, but the next model, which is a DevOps, improves how the software to be delivered and maintained also, which is like focusing the deployment. So the agile ends at the development stage. Agile ends with development. Once the development is done, the agile will conclude there. DevOps takes the responsibility till production deployment. Agile is an iterative approach. You can see in the image, right? It is an iterative approach where software is built in small pieces with a continuous feedback. With a continuous feedback. Now, after this agile model, which was introduced in 2001, right? The next model is the DevOps model, which is the popular model. We are here for this DevOps model, right? Not to learn the DevOps model. With the help of the DevOps model, we are going to manage the end-to-end things. This DevOps model was introduced in 2009. So a person called Patrick Debois organized the first DevOps Day conference in Belgium. The goal of that DevOps Day was to break the wall between the development and operations. That's what exactly we need for a smoother and effective way of delivering the applications. DevOps is a working model. Already I said, right? DevOps is a philosophy. It's not a technology or it's not a kind of a coding language. It's a process. It's a philosophy. It's a cultural philosophy which we have to follow, where development and operations work together using automation to deliver software continuously and reliably. In the DevOps model, always you see a term called continuous. Everything is continuous. Continuous testing, continuous build, continuous integration, continuous deployment, continuous monitoring. It's a kind of a continuous. That's why in the DevOps model, there is it is an infinite loop. It is an infinite loop, which you can see on the screen. Continuous feedback will be collected and improvements will be continuous. DevOps model flow. It starts from here, planning phase. If you observe, all the phases are same. Plan, code, build, test, release, deploy, operate, monitor, maintenance, or whatever. Okay. So here in the planning phase, what they will do? Features are planned, tasks will be created. They use some tools like Jira, right? Where create some kind of Kanban boards, create tickets, tasks assigned to the developers, right? There are a number of things. We can use anything, but Jira is a popular one. That's why I mentioned that term. Tasks are created. Then in the code, the developers will write the code. Developers write the code, and the code should not be stored in a local computer. The code will be stored in the VCS, version control systems, like a Git, or I mean, like a distributed version controlling systems like GitHub, GitLab, Bitbucket, right? Or a code commit in AWS. Different companies will use different things, but the popular ones we can learn. The concept is going to be the same for all the tools. Once the code is ready, in the build phase is the second phase, and a build phase is a third phase, where code should be compiled and artifacts to be created. Artifact means, let us say, a .exe file, right? This is the example of the artifact, because we never ever provide code directly to the end users. We will provide an executable file, artifact. So here there are some build tools like Maven and npm make, right? Depending on the coding, if the application is a Java application, Maven, there is something called a pip. If it is a Python application, you have to use a pip. If it is a React or something, then you can use yarn and yarn something. It depends on like what code programming language is used. So we learn Maven, right? And the artifact has to be generated, and that, right, it must be continuously integrated. Okay, let me tell you. I will come back to this continuous later. Once build is ready, that will be tested not only by the QE team. QE team will do some functional testing, right? But we do some security testing. Like if it is Java application, they do use some kind of jar files, whether they are using the appropriate jar files or not. Or does the developers use very outdated or old jar files which are vulnerable, right? So we do perform some security testing like using Sonar Cube, security related. Automatically, this security will be executed and it will generate a report. How many outdated versions you are using, how to replace them. It will generate a vulnerability score. And in the release phase, code is approved. Once everything passed, the code is approved, right? And that is ready for production. Ready for production. Then the deployment is like applications to be deployed. Applications to be deployed means installed. infrastructure to be created, and in the DevOps, there should be no manual intervention. So here you will learn something called cloud, like AWS. And in the operate whatever the applications we installed, right? Those applications to be run in the production, servers to be created, and the containers to be created. If the application is a containerized application, the containers to be created. So here, Docker is there, Kubernetes clusters KTS, or something called in the deploy stage itself, you will see something called Terraform IAC, infrastructure as a code, which is like Terraform. Like in each phase, we use different tools. Once everything is operated, right? Everything is up and running. Monitoring is most important. The performance will be monitored. If there are any errors, those errors will be tracked. Feedback will be collected. Like here, let us go back to here. Here, like let us say the CloudWatch, right? Or a Prometheus, Grafana, Helm charts. These are the monitoring tools. They are the popular nowadays. But in the olden days, we do have something called Nagios, Site 24/7. Those are all like different things. So here, these are the popular ones: Prometheus, Grafana, Helm. Whereas the CloudWatch is AWS related monitoring tool, where you can do a resource monitoring, right? Where you can do resource monitoring, you can observe like what is happening, how much CPU is getting utilized, right? Or how much memory is getting utilized, whether your machines are overutilized or whether your machines are underutilization. And again, we have to monitor to save the money also, not only for the performance. Let us say a simple example. I created one server. Let us say I created one server. Just how a DevOps guy should work in the real time. Okay, I created one server. Okay, in which I provisioned 8 CPU and 64 GB of a RAM, which cost me, let us say, $10 per month, just for an example. And in the monitoring phase, in the CloudWatch, you observe that the CPU utilization is just 1% and the RAM memory utilization is just 15%. What you will do means, based on the, like, not only for a single hour or a single day, for the entire month, from the last couple of months, the graphs are showing the CPU is just at 1% of utilization and the RAM memory is just 15% of utilization, which means my server is over provisioned. Over provisioned means over provisioned with resources, which means it has more resources than the requirement. More resources than the requirement. Why should I pay? Like means here I have 8 CPU and 64 GB, but in the real, I'm using just one CPU and 8 GB of RAM. Unnecessarily, like what we call that. If you are planning to buy a laptop just for internet browsing, or you are purchasing a laptop for your parents, so that they can do some kind of online shopping or they can do some video calls with you, right? Do you prefer to buy a machine with a 64 GB of a RAM and i7 15th generation processor and all? Not required. If you buy it, that's not a problem, but you have to spend more money, but they can't use all the resources. The resources will kept idle, unused. For without any usage, why should we pay that much money, right? The same process here, the observability, the monitoring plays a crucial role in the DevOps lifecycle. So every month they generate reports and they will observe what machines, what instances are not utilizing the resources effectively, and they will downsize the server capacity. They will reduce that from this to 4 CPU and 32 GB RAM or 4 CPU and 16 CPU of RAM. You might ask a question, what if that 4 CPU and 16 GB RAM is not enough? The performance is not good. Immediately they can upsize one bit level, like a 4 CPU and 16 GB RAM. Instead of 8 GB RAM, they will go with 16 GB RAM or 32 GB RAM. But they can save something, right? They can save something instead of unnecessarily allocating 8 CPU and 64 GB of a RAM, right? Okay. In DevOps, so here we will get the feedback, right? At monitoring stage, we'll get the feedback in DevOps, and this feedback goes to planning continuously. Whatever the feedback you are getting, not only for the monitoring, from the customer also you will receive a feedback, right? That will be go to the planning phase again. That's why DevOps is a loop, not a line. In DevOps, continuous integration, continuous testing, continuous deployment, continuous monitoring will happen. Example, here I will explain what is this continuous integration and all. So the developer, let me change the color. Yeah. So the developer completed the coding and they will push the code into, let us say, GitHub, a VCS, GitHub, right? Then automatically a build will be triggered. So here we use a tool called Jenkins, continuous integration and a continuous deployment tool. The moment once the developer push the code, build tool, Jenkins will trigger the build tool. Maven generates an artifact, right? Immediately automated tests will be get triggered automatically. And automatically it will be deployed using the continuous deployment tool with the help of a Jenkins. Let us say it's a Tomcat application. This artifact, it will generate a jar file or a var file, right? This will be automatically deployed into a Tomcat application, and the application will be up and running, and automatically a monitoring will be triggered, monitoring will be created, and the health has some issues, automatically it will roll back. It will revert all the changes. Means if you are pushing a new update, if something went wrong, automatically that will be rolled back. Even the client doesn't identify that something went wrong and they reverted. All will be within few minutes, like seconds to minutes. Now, based on all these, can you tell why DevOps? Before DevOps, developers always focus on new features. They don't care about like the operations thing. Operations team always focus on stability. Like their job is to maintain the applications up and running all the time, right? So why DevOps? Because the companies will never or ever don't care about the tools. They are care about their customers, the money, and the uptime. Uptime means, what is the meaning of uptime? How much time the server is up and running, right? That is what the uptime is, right? So if your server is like 24 by 7 up, that's very good, right? Availability. Yes, uptime is like 24 by 7 or availability. That's correct. So always the job, not only for DevOps, even if you're working as a cloud architect, your job is to make the application with high availability. Like the industry standard is like 99.99% of uptime. So DevOps exists to protect all three. Before DevOps, how the life was before DevOps is very slow releases, right? In the waterfall model, they have to wait like 6 months or 1 year, and everything is a manual deployment, frequent production failures because of no proper planning in the operations, downtimes. Because of that, we get downtimes, and the customers complaints whenever the application is keep on crashing. They won't care you, right? They will leave your company, and your company will lose the revenue. Like if a shopping website goes down during a big billion day sale or Amazon Great Indian Sale, what happens? the company losses huge, right? Per minute, they will lose like lakhs of rupees per second, right? So why DevOps is DevOps connects the development to the production. Earlier, code was written fast, but the delivery was very slow and risky. DevOps ensures safe and secure delivery, and even though the fast delivery of the application. With DevOps, features go live quickly, bugs are fixed faster. Always the stability matters. Frequent failures damage the trust, right? Customer leaves if the application crash. DevOps helps by automate the testing, monitoring, and a quick rollback. Always the automation reduce the human errors, right? I think everybody will agree that, right? But you have to do the automation properly. So with DevOps, we can automated pipelines and get consistent results. DevOps always replace manual stress with automation. Continuous feedback always improves the quality. Let's say if you are doing something, if there is some person who is continuously monitoring you and if they are giving you the feedback, you can learn quickly, right? The same thing. Continuous feedback always improves the quality. Monitoring, right? The dashboard show the real problems. Logs reveals the issues. Metrics is nothing but CPU utilization, memory utilization, disk utilization, network bandwidth utilization, disk read operations. These all are known as the metrics. The metrics guide the improvements. Let us say if the CPU is always greater than 80%, what this metric will guide you? Your system is running with low CPU. It requires more cores or more CPUs. The metrics will guide you how to do the improvements. And DevOps improves the team culture. Earlier, whenever the development and operations are working separately, there was not that much team culture. They blame each other like the code is good, your operations environment is not good because the developer says the code is working in my laptop, so it should work in your environment. And the operations team says, okay, because of the code only the application got crashed. There's a kind of a blame game. But with the DevOps, there is improved team culture, no blame games, shared responsibility, and better collaboration. In DevOps, success and failure belongs to everyone. Belongs to everyone. This is the reason why the DevOps is more popular. Even still, it was introduced in 2009, right? It was introduced in 2009, and still the DevOps is more popular, and still there has more room for DevOps engineers in the market. There is very high room, I mean, the space, the scope to get a jobs in the DevOps in the market. It was introduced in 2009. Just in this session, there's a day 01, right? Yesterday was a day 0, a demo kind of a thing. In the day 1, today's video, just we had some conceptual knowledge about DevOps, why DevOps, right? Like what is SDLC and what are the different models. And nowadays, no one is using the waterfall model. But still, there are few companies which are using the Agile model. Still, Agile is popular because it solves the development problems, right? Still, there are some companies who are using the Agile methodology. I think you might have something called a Scrum Master certification, right? Those all are a part of Agile methodology. But whoever is following the Agile, they solve the development problems. There is no doubt in that, but deployment issues remain. Slow deployments because the manual. That's why Agile team still had a stressful release days. In DevOps, always we rely on the feedback from the production because feedback is more important than assumptions. Okay, right. So any questions so far? Anybody having any questions? Just you can use the chat box if you have any question, or click on raise hand button so that you will get unmuted and you can ask the questions directly also. Okay, in the meanwhile, while you are getting or while you're preparing for your questions, let me tell you a few things. In the tomorrow session, we will start with the Linux commands. I don't take like Linux commands like for 1 month or so, because being a DevOps engineer, you are going to execute some Linux commands also. All the production servers to be on Linux machines, like the tools will be installed on the Linux machines like Jenkins, right? Docker, Kubernetes. So you must have some basic commands. Don't worry, no need to by heart the commands, just you need to understand what commands or which command does what operations. That's more than enough. Okay, right. So tomorrow we will see the Linux commands. First, we will start with some basic like how to log into the Linux machine. If you're having a Linux laptop, directly you can log in. But in the real time, in the companies, we don't go to the server room and we don't sit in front of the Linux server to log in. We will do a remote login. For that, we use SSH secure shell. What are the different methods that we can log in? What are the SSH client we have to use, like Mobaxterm, Putty tool, whatever, like any one tool. We will connect it. We will see the basics like how to uh, perform some basic commands like create files, create directories, and create user, change permissions, change ownership, create a file, add content, edit the data, set parameters, set patterns. Let's complete that in the tomorrow session. Like whatever is required for a DevOps engineer, those commands we will complete. Like view the files, list the files, hidden files, everything. I will prepare the list of commands, and not only like executing the commands, we will try to understand how it works. We will do it practically. We will observe and we will note down some points also. Okay. This is about the today's session. Tomorrow we'll go with the Linux commands. Once we're done with the Linux commands, then we will start our first DevOps tool, Git. That is most probably day after tomorrow. Git, GitHub, integration like cloud, everything. Like we will go one by one. Okay. So you can one more small announcement. So you can attend these sessions without any payment, without any pay for the first 5 days until the Saturday. If you feel confident, if you are comfortable that you can continue or you are able to understand, you have something to learn, then only you can make the payment, right? I will share all the details in today's email along with the recording link of today's video. Just go through the video, and this is not a kind of forcing you, right? Just an intimation. No need to make any payment until the Saturday, right? Because uh, few people will join, not from my session only, anywhere, like without attending any demos, without understanding what they are going to learn. I'm not blaming the trainer. Let us say if someone is not interested in all these things, right? Just he might attend the demo session. He feels okay, whatever is delivered by the trainer is clear, crystal clear, and I'm able to understand his words. I'm able to understand his slang and everything. He might get joy. But after few 2 days or 3 days, whenever the actual concept starts, he might get confused, right? That's why no need to hurry. Just attend the first 5 days until the Saturday. After completing the Saturday session, also go through the recorded videos. If you think you have interest and you are able to follow the my sessions, then only you can make the payment and you can join for the rest of the course. By then, we will start our Git tool also. We will complete that Git, at least Git, not the GitHub, right? You will get some clarity about whether to continue with the DevOps journey or not. Okay, right. Before closing the today's session, are you guys clear or any questions? Anyways, whatever the registered email you have provided, right? On that email, I will send you the recorded video and all the details, right? Yes. Yeah. Thank you, everyone. If you have any questions, just you can wait. If you guys are clear, you guys can leave for the day. Thank you, everyone. We'll continue tomorrow.